This is what would happen if our planet, spinning right now, faster than the speed of sound, suddenly brake to a standstill for 60 seconds. A 1-minute pause in Earth's rotation would set off 2 back-to-back extinction-level events, and the physics behind all of it turns out to be disturbingly simple. Most people never stop to think about this, but you are not standing still right now. Anyone sitting near the equator is moving at 1,674 kilometers per hour, which comes out to 1,040 miles per hour. A 9mm bullet travels at roughly 784 miles per hour, which means you are outrunning a bullet at this very moment. Your speed clocks in at Mach 1.4, 36% faster than the speed of sound, and you feel absolutely nothing. Everything around you moves at the same speed. The air, the ground, the oceans, the buildings, even your coffee mug. 4.5 billion years of spinning gave everything on this planet plenty of time to catch up. That speed drops off as you move away from the equator though. 30 degrees latitude, roughly where Cairo and Houston sit, still clocks in at 1,450 kilometers per hour, faster than the speed of sound. 45 degrees, around Portland, Oregon, or Milan, brings you down to 1,183 kilometers per hour, which still outruns a commercial jet. Anchorage, Helsinki, and St. Petersburg, at 60 degrees latitude, cruise along at 837 kilometers per hour, about 2.5 times faster than a NASCAR car at full throttle. Only at the poles does the number drop to 0, where you just pivot slowly in place. All of that momentum, all 7.5 billion people, all the oceans, the entire atmosphere, every building and bridge and mountain, all of it hurtling eastward at supersonic speed. And then the ground stops. The energy locked inside Earth's spin sits at approximately 2.14 times 10 to the 29th joules, a number so absurd it means almost nothing on its own. Translated into something you can picture, that equals over 1 trillion tsar bombas, the largest nuclear weapon ever detonated, all firing at once. 1 million Chicxulub asteroid impacts, the ones that killed the dinosaurs, would still fall short. Every nuclear warhead on the planet adds up to 1/trillionth of the energy needed to stop the spin. This is not some gentle wobble. Newton's first law tells us that everything riding on a freight train that size wants to keep going. When Earth's solid body decelerates to 0 over 60 seconds while everything else keeps its momentum, the forces hit immediately. A sideways deceleration of approximately 7.75 meters per second squared slams into everyone at the equator, equal to 0.79 g, roughly 3/4 of normal gravitational pull, except it shoves you sideways. 3/4 of a g does not sound that dramatic on paper. Astronauts handle more during launch, and some roller coasters push harder. But here's the thing. That sideways force tilts the apparent direction of down by 38 degrees from vertical. BBC Science Focus ran the numbers on this exact 1-minute scenario, and the conclusion came down to one sentence, quote, "That's enough to knock over most buildings." They're not exaggerating. Structural engineers design most buildings on Earth to handle lateral seismic loads between 0.1 and 0.4 g, which means the force from a 1-minute stop nearly doubles the maximum load any building on Earth was designed to survive. And this force does not hit one fault line or one city. It hits every structure on the planet at the same time. None of that matters much though, because the buildings falling over ranks as the least of your problems. While you and the ground beneath you slam to a halt, the atmosphere keeps moving. 5.15 times 10 to the 18th kilograms of air, carrying its full eastward momentum, does not care that the ground stopped. At the equator, air that moved with you at 1,674 kilometers per hour just became a wind blowing at 1,674 kilometers per hour, Mach 1.37. Supersonic wind, coast to coast, pole to pole. That calls for some context. Hurricane Patricia in 2015 holds the record as the strongest hurricane ever recorded in the Western Hemisphere, with sustained winds of 345 kilometers per hour, and the winds from a rotational stop at the equator blow almost 5 times harder than that. The 1999 Bridge Creek to Moore tornado generated the fastest tornado winds ever measured at 517 kilometers per hour, and equatorial stop winds still triple that number. These are not strong winds in any normal sense. Supersonic shock waves sweep across the entire planet, generating continuous sonic booms on every surface they strike. Debris stops being debris and becomes high-velocity projectiles moving faster than bullets. Atomized spray erases the boundary between ocean and atmosphere, Frictional heating from supersonic airflow scorches every exposed surface, and the kill zone stretches wider than you'd expect. Winds stay supersonic all the way down to roughly 42 degrees latitude, because at that angle, the cosine of the latitude brings rotational speed down to approximately 345 meters per second, the speed of sound at sea level. Everything between 42 north and 42 south falls inside that band, and about 85% of Earth's population lives there. Even at 60 degrees latitude, Anchorage and Helsinki territory, the winds still blow at 837 kilometers per hour. That doubles the wind speed of the strongest hurricane ever recorded, and nothing in human engineering handles that kind of force. Survivable conditions exist only near the poles, within the last few degrees of latitude, which happen to count among the most inhospitable places on Earth for completely different reasons. NASA captured the whole scenario in one line. Quote, "If the planet stopped suddenly, everything on the surface would be destroyed, as the atmosphere, oceans, and anything not nailed down kept spinning. Water behaves differently from air, and the difference comes down to mass. Earth's oceans weigh approximately 1.335 times 10 to the 21st kilograms, which makes them 269 times heavier than the entire atmosphere. Every cubic meter of seawater carries the same eastward momentum as the air above it, just packed into far more mass. When the ground stops, the oceans keep moving. Water slams into every east-facing coastline on Earth, at speeds ranging from hundreds to over 1,000 kilometers per hour. No peer-reviewed paper has ever modeled the exact wave heights for this scenario, because it blows past every natural analog we have, but comparison paints the picture. The 2004 Indian Ocean tsunami killed approximately 228,000 people, with waves reaching about 30 meters at the coast. Waves from the 2011 Japan tsunami hit 40.5 meters and drove 10 kilometers inland. Even the Chicxulub impact 66 million years ago, which triggered the largest tsunami in the geological record, sent out initial waves estimated around 1,500 meters, and that still radiated from a single point source. A rotational stop generates something fundamentally different. A simultaneous global directional surge where every ocean on Earth moves eastward at once. No coast sits on the safe side. No high ground climbs high enough. Kinetic energy in the oceans alone reaches roughly 10 to the 26th joules, billions of times the energy released by the 2004 Indian Ocean tsunami. There is also a slower building effect worth knowing about. Rotation currently pushes ocean water toward the equator, building an 8-kilometer bulge in sea level compared to what a non-spinning Earth would have. ESRI scientist Witold Fracek modeled this redistribution using ArcGIS and found that without centrifugal force, oceans would migrate toward the poles over weeks to months, creating two massive polar mega-oceans while exposing an equatorial megacontinent that wraps around the globe. Everything north of roughly Spain's latitude would go underwater. That full redistribution takes far longer than 60 seconds to develop, but the initial inertial surge starts instantly. One system barely registers the chaos, and that might come as a surprise. Earth's magnetic field would hold steady through the entire event. Popular science coverage often gets this wrong by claiming the field would collapse. The geodynamo, powered by convection currents of liquid iron in the outer core and organized by the Coriolis effect from Earth's rotation, generates the field. The word to focus on is organized. Convection itself runs on heat from radioactive decay and inner core crystallization, not rotation. And the magnetic field's ohmic decay timescale, the time it takes the field to fade on its own without a dynamo, stretches to approximately 15,000 to 20,000 years. A complete shutdown of the dynamo would leave the existing field intact for millennia. During a 1-minute pause, the liquid outer core keeps flowing on its own inertia, and the Coriolis organized flow patterns experience minor disruption at worst. Field strength, 30,000 nanotesla at the equator and 50,000 at the poles, holds steady through the entire 60 seconds. Mars offers a useful comparison. Its core cooled about 4.2 billion years ago, and the global magnetic field disappeared. Solar wind then stripped the atmosphere, but that process stretched across hundreds of millions of years. Earth's magnetosphere would keep blocking solar wind through every second of this apocalypse. Cold comfort, but real comfort. Beneath the surface, Earth's shape tells its own story. Our planet is an oblate spheroid, wider at the equator by 42.77 kilometers than from pole to pole, and that bulge exists entirely because rotation pushes mass outward. Without spin, the equilibrium shape would trend toward a perfect sphere, That shift takes time, though. Earth's mantle carries a viscosity of 10 to the 21st to 10 to the 22nd Pascal seconds, so thick that the solid planet reshapes over thousands to tens of thousands of years. Scandinavia is still rebounding upward from ice sheets that melted 10,000 years ago, which tells us exactly how slowly rock responds. 1 minute changes nothing measurable about Earth's shape. Tectonic plates tell a different story. Sudden deceleration hammers every fault line, every subduction zone, and every volcanic system on the planet, with forces beyond anything in the geological record. The 2004 Sumatra magnitude 9.1 earthquake changed Earth's oblateness by 1 part in 10 billion and shortened the day by 2.68 microseconds, and stopping rotation entirely unleashes forces many orders of magnitude beyond that. Massive earthquakes and volcanic eruptions follow with near certainty, though no published estimate pins down specific magnitudes for something this far outside our experience. Below the mantle, the liquid outer core adds another layer of chaos. A sphere of molten iron nickel with a radius of about 3,480 kilometers carrying its own angular momentum does not stop just because the rock above it stopped. That core keeps flowing and shearing against the now stationary mantle in ways we have no precedent for, though at this point in the scenario, the question is mostly academic. After 60 seconds of planet-wide destruction, Earth starts spinning again, and everything reverses. During the 1 minute pause, friction between the atmosphere and the surface only partially slowed the air and oceans. The atmosphere's settling timescale runs far longer than 60 seconds. When the ground suddenly accelerates back to 1,674 kilometers per hour, air and water lag behind all over again. A second wave of supersonic winds hits, this time blowing from the east instead of the west, followed by a second round of mega tsunamis and a second pulse of seismic destruction. Anything on the surface that somehow survived the first event gets leveled by the second. 2 sequential supersonic wrecking balls, separated by 60 seconds of false calm. Randall Munroe of XKCD delivered what might be the most perfectly understated summary of total planetary annihilation ever written, quote, "Nearly everyone would die, then things would get interesting." And here is the part that deserves its own section. Because Earth's rotation actually is slowing down right now. It has been for billions of years. The Moon's gravity raises ocean tidal bulges that get dragged slightly ahead of the Earth-Moon line by our faster rotation, and friction between the moving water and the seafloor bleeds off about 3.78 terawatts of energy. That friction lengthens Earth's day by approximately 2.3 milliseconds per century, a number that sounds trivial until you stretch it across geological time. Physical proof sits inside ancient fossils. A Cornell scientist named John W. Wells counted daily growth rings in Devonian-era corals back in 1963, examining fossils about 400 million years old, and he found roughly 400 rings per annual band. The Devonian year contained 400 shorter days lasting about 21.8 hours each. Go all the way back to Earth's formation 4.5 billion years ago, and a full day lasted approximately 6 hours. That slow drain of rotational energy also pushes the Moon away, at 3.82 centimeters per year, a distance measured precisely by bouncing lasers off reflectors the Apollo astronauts left behind. Full tidal locking would arrive in about 50 billion years, with Earth always showing the same face to the Moon, except the Sun becomes a red giant in about 5 billion years, which makes the timeline irrelevant. This tidal slowing creates real headaches for modern technology. 27 positive leap seconds have been added since 1972 to keep clocks aligned with Earth's gradually lengthening day, and the last one landed on December 31, 2016. Earth has actually picked up speed recently, though. June 29, 2022 finished 1.59 milliseconds early, making it the shortest day since precision measurements began, and scientists have floated the possibility of a first-ever negative leap second around 2029. Even individual earthquakes nudge our spin. 2.68 microseconds disappeared from the day after the 2004 Sumatra earthquake. 1.8 microseconds vanished after the 2011 Japan earthquake, and filling China's Three Gorges Dam, just moving that volume of water to a higher elevation, added 0.06 microseconds. NASA's Richard Gross put it this way, quote, "Any worldly event that involves the movement of mass affects the Earth's rotation, from seasonal weather down to driving a car." After everything we just covered, though, there is a reassuring bottom line. Smithsonian geologist James Zimbelman told Space.com, quote, "This is just a thought experiment. There is no natural force that would stop the Earth from spinning. No asteroid, no gravitational event, and no cosmic phenomenon in the foreseeable future of our solar system carries enough energy to halt Earth's rotation. Over 1 trillion Zarbambas worth of energy simply does not exist in any known natural source. Our spin is safe. What makes this thought experiment worth running is what it exposes. The gentle breeze, the rising and setting of the sun, the tides, the shape of our continents, the fact that our atmosphere stays where it belongs, all of it hangs on a 4.5 billion-year-old spin that we cannot feel, cannot see, and almost never think about. You are hurtling through space right now at over 1,000 miles per hour, and the only reason you're alive is that everything around you is doing the exact same thing. Next time someone asks what you did today, you can give them the honest answer. You survived another day on a supersonic rock flying through the void, held together by nothing but momentum and gravity, and you didn't even spill your coffee. If you enjoyed this one, hit that subscribe button so you don't miss what's coming next. Drop a comment and tell us if Earth stopped for 1 minute and you could pick any spot on the planet, where would you ride it out? A hint, think as close to the poles as possible. We'll see you in the next one.